All right, let's go. So today's lesson is going to be pretty straightforward and quick. We are just simply doing what they call surface areas. In order to do it, it does mean you have to revise or at least know 4C, 4D, and 4E formulas. What do I mean by that? You need to know the area formulas for a square, rectangle, triangle, parallelogram, kite, rhombus, and trapezium, along with a circle. So you need to know all the formulas for those. Now that's 8 shapes in total. Okay, so yesterday I did a bit of a revision. Today I said I am going to now ask you individually just to recap the formulas so that you remember. What was the formula again for a square? Can I please have, let's go with Tom. What's the formula for a square again?
Length times width.
Yep, length times width. But since a square has all the same sides, the width is actually the same thing as saying length times length. Okay, but if it helps you to remember, just say length times width. Yeah? What about a rectangle? Can I please have Haoshuan? What's the formula for a rectangle again? Length times width. Very good. Length times width. What about a triangle? Can I please have Leon? Sorry? I want the area formula for a triangle. Very good. Length times width divided by 2, or if you learnt it as base times height divided by 2, either way it means the same thing. Yeah, because the base is the flat, and then the vertical height, see how it kind of looks like length times width? Same idea. Yeah, so length times width, and you have it. Very good. What about the parallelogram? What's the formula again? Let's go, Wilbur. Base times height. And again, a parallelogram is actually the same as a rectangle, just looks a bit different. And so we usually say it's this. But you see where I cut here, if I cut that triangle and then place over here, you get a rectangle. So that's why it's length times width again, or base times height. Either way, means the same thing. So base times height, or you can think of it as length times width. So all of them, it's pretty much length times width in some form. So 4C should be the easiest to memorize because it's the same formula across. It's all mainly rectangles. Yeah? Then you move on to 4D. Let's see if you remember. So there's only 2 formulas to remember because a kite and a rhombus has the same formula. What's the formula again for a kite or rhombus to find the area? Let's go, Kyle. Good. Diagonal 1 times diagonal 2. And then half. Very good. So the diagonals in those shapes, so the diagonals, times them together, and then halve it. Okay, so the diagonals of the kite, halve them. That's what D1, D2 represents. The hardest one to remember was the last one. What shape was that again? Trapezium. This is a trapezium. And how do you know it's a trapezium? It has to only have one pair of parallel lines, and that's part of the formula. If you have one pair of parallel lines, we can call that A and B. That's a hint to remind you of the formula. So trapezium. Hands up if you remember the formula for trapezium. Oh, Mateo.
Yeah. Is it like you split into 2 shapes?
Oh, yes, you could too. That is another way too. That is, so if you split it up into 2 shapes, you can get 2 triangles of rectangle and you can get the same answer as well. But there is a shorter way, which is the one formula to need that you can just use. Ashwin? Ooh, so close. Let's finish it off for Ashwin. Half of what? Kyle? Good. A plus B times height. So height is what that vertical distance between A and B is. So once you find the 2 parallel lines, add the 2 parallel lines. That's what A plus B means. The distance between them has to be the vertical distance, yeah? 90 degrees, not the slant. So the vertical distance is your height, then you half them. That arguably is the hardest formula to remember, so go back to 4D if you've forgotten how to do them. But that's your 7. And then the one we finished off yesterday, circles. What's the formula for a circle again? Let's go with Tilly.
is like theta.
Oh, yeah.
Times radius.
That's true. You do have a radius. The first one, it's a symbol.
Oh, pi.
Pi, very good. So pi times radius, but there's something about the radius you have to do again. Liam. Has to be squared. So pi times radius squared will give you the area, but depends on what part of the area do you want. So what's the next bit, Leon?
So divided by 360.
Good. The theta over 360 tells you which portion of the circle you want. So whether you want half of it or you want full circle, that's what the theta is for. Okay? So that's a summary of your 8 rules that you need to know in order to then work on 4G. Because 4G is just looking at the outside shapes, and you have to know all the different shapes to then add them together. So here's an example for today's lesson. Total surface area. This will have to do with 3D shapes. Okay, so you have to kind of visualize the 3D object in front of you. Total surface area is another way of saying if I had to paint the outside of this 3D shape, what's the total area that I need? Yeah, because when you paint the outside, they become 2D. So the outside of a 3D is always 2D, each plane. Yeah? So here's an example. Total surface area is the sum of the areas of all its faces. Okay, so a 3D shape has to have faces. So here's an example. This is what you've done in primary school, which is called a net diagram. It shows you the actual flat look of what the 3D shape looks like. Then you fold it all together and you get yourself a 3D cube. But this 3D object has the front face, it has the back face, then it has the 2 sides, so the right side, then it has the left side, then you also have the top that you're going to paint, and then the bottom that you have to paint. So there's 6 sides in total. Yeah, so it's about you visualizing. When they give you a 3D shape, can you visualize that? Because each one is a different shape. In this case, it's all nice and easy. They're all squares. Each one is a square. So we already know the area of a square. And that's what I meant. You had to know all your 8 rules to work out so you can add all the faces together. So here we go. How many faces does a cube have? Can I please have man? 6. Very good. We can count it 1, 2, 3, 4, 5, 6. So that means there are 6 faces. And luckily for us, all the faces are the same shape. They're all squares. So because they're all squares, you're doing L squared plus L squared plus L squared plus L squared plus L squared. Now, if you're wondering why it's L squared, because length times length in the formula before, length times length is L squared. Okay? All right, let's put it together. So in a cube, I just need to know what one of the sides is. If the side was 3, so as an example, if L was equal to 3, then it'd be 3 squared. Now be careful, 3 squared is not 3 times 2. It means 3 times 3, which is 9. So in this example, you would have had a total surface area of 6 times 9, 54. And because I didn't give you any units, you can then just say squared units. Okay? All right, team. Let's try one example. And that's it for today's lesson. Flip to the first example, example 1. Oh, not flip, but scroll down. Here we go. First example. You've got a 3D shape. This is called a triangular prism or triangular prism. You've got a prism. You have to visualize now, if I were to flatten this 3D shape, how many different faces do I have and what shapes do I end up? So just looking at this, how many faces will this have? Can I please have, let's go with Oliver. How many faces will you have? 5, very good. So we got front, we got the back, we got the 2 sides. So that's 1 and the back as well. And then you got the bottom. Okay, so that's 5 there. So I've colored in 2 greens, front and back, on the right angle and the left angle in pink. So that's 2. And then plus 1 on the bottom. That's in total now 5. Okay? But we have to now identify the shapes. So just identifying the front and back. The front and back are the same shapes. What is the shape? Yes, Ashwin?
What is it? Something pyramid.
No, this is a triangular prism, but I'm just talking about the very front. What shape is that? Triangle. Very good. So the front and the back is a triangle. So your job is to find, well, what is the area of a triangle again? Let's go with Ava. What's the area of a triangle again? Good. So length times width over 2. Beautiful. Okay, so again, you got to find the base times the height. In this case, you can see the base is 6, height is 4. So let's write it in. Base is 6 times width, which is 4. Shh, don't speak while I'm speaking. Close the laptop, please. Thank you. No, don't speak while I'm speaking. And if you were playing games, only you would know. Don't lie to yourself if you were playing. Good. All right. Yeah, you don't need it. You don't need to defend yourself. If you have to defend yourself, you're lying. Okay. It's like a rich person. Do you think Elon Musk has to go around proving to people that he's rich? He doesn't. He just knows. So if you have to prove it, probably means you're not. All right. Next one. 6 times 4 divided by 2. So let's work that out. 6 times 4, which is 24. 24 divided by 2. 12. But since you got the front and you know the back's exactly the same, you don't have to work it out for the back again. We know the answer is 12 and 12. So total so far, you got 24. Okay, so we just need to work out the front and the back, but since they're both the same triangles, we've got the front and back, which is 12 and 12. Good. So we said 5 faces. We've done 2 of them. Now we need to do, let's say we do the sides. What shape, if you had to flatten this, what are the 2 sides? Rectangles. So then the 2 sides, we know that we've got 2 times 2 rectangles. Area of a rectangle, Bo? What's the area of a rectangle? Base times height. Very good. So length times width or base times height, same thing. So length times width. And let's have a look at this rectangle. So I'm going to draw it. Here's my rectangle. What is the length and width of this case? Let's go with Tom. So looking at this side, which is a rectangle, what is the length and width? 10 and 5. So here we then say 10 times 5. That's for one rectangle. 10 times 5 is 50. But remember, you got 2 of those rectangles. So we're going to double it. 100. Beautiful. So now we've got all 4 sides already. We've got 2 of the sides. We've got the front face. We've got the back face. We're only missing the bottom now. So we now need to color the bottom as well. And again, you identify what shape that is. Rectangle again. So this one's a nice rectangle. So then, same thing again. We've got a rectangle, length times width. But our dimensions, what's our dimensions here? Let's go with Haoshuan. The bottom rectangle in blue. 10 and? 10 and 6. Beautiful. 60. So when we say, what's the total surface area? We're saying, if you added all those areas together, what's the number? So we had 2 triangles, so 12 plus 12. We had 2 rectangles, which was 50 plus 50. And then now we just worked out the last bit. Another rectangle, which is 60. Let's put it all together. 50 and 50 was 100, like you said. 100 plus 60 is 160. Then plus 12 and 12, which is 24. What's 160 plus 24? 184. Very good. I was going to say, what are we missing? We're missing, and remember, it's not read as centimeter squared, it's read as? Squared centimeters. Good. There we go. That's 4G. So different shapes will have different compositions. You have to identify all 8 rules. So you got circles, rectangles, square, parallelograms, kite, rhombus, trapeziums. You have to know all of them in order to get to this final answer. It's one of those tedious exercises, but it's one of the easy exercises as well. Okay, so as long as you know your formulas and you've got a calculator, should be doable. Key takeaway for this exercise is your layout. See how I put it out? I list out what I'm actually solving. The layout is key. If you try to do it all in one step, you're more prone to mistakes. So practice laying out. Lay out your thinking. That's one of the hardest things to teach junior levels. Teaching you to think in steps in logical order. Okay? All right, that's it for today's lesson. So you got 4E, 4F. And just as a reminder, if you didn't know, next week on a Friday, I won't be here because I'm on a PD called Big Day Out. So that session will be your session. So if you're feeling like there's a lot of work so far, next week you'll have one session that's your time. Okay?
How do you find the